Hello pre-calculus students, we continue our lesson on trigonometric proofs, and I'm going to show you another strategy to doing a proof today, and this is called using the difference of squares. So before we actually get to the proof, let me just remind everybody what difference of squares really means. So if you remember from your algebra days, if you have this equation, this problem, x plus y times x minus y, well, we FOIL. So you get x squared minus xy plus xy minus y squared. Okay. The two middle terms here cancel because you have minus xy and plus xy, so you end up with x squared minus y squared. There's no middle term here. So a lot of people are able to do this and are able to get to this point. When you're doing proofs, sometimes you're given this problem, a squared minus b squared, and you can see from what we've shown up here that this can be expanded to a plus b times a minus b. Okay, because if we took this and FOILed it, the middle terms would cancel as well, and we end up here. So it's easy to go from the expanded form into the condensed form, but it's sometimes difficult to see it, and I just want to remind you of this, that when you have a difference of squares, you can actually expand it to a plus b times a minus b. So let's keep that in mind. Put that thought in the side of your brain for just a minute, and we're going to go back to this pretty soon as we work into our proof. Okay, so this is the proof that we're given, and this is trying to show that cosine over 1 minus sine is really the same as 1 plus sine over cosine. So in this proof, I'm going to start with the left hand side and show why it is equal to the right hand side. Okay, and this is all given. So I'm going to multiply this by 1 plus sine over 1 plus sine. And so this is multiplying by 1. Okay, we've seen this before, we've seen this many times. But if you notice in the denominator, once I multiply this out, I'm going to end up with a difference of square problem. Similar to what I had here. When I had x plus y times x minus y, in my denominator here, I'm going to have 1 minus sine times 1 plus sine. So it's very similar to this scenario, and we'll see how this plays out. So let's multiply the numerator, which will give me cosine of x times 1 plus sine of x. And in the denominator, I get 1 minus sine. Again, these brackets don't mean anything different than parentheses. Just a way to see everything a little bit clearer. So in the numerator, it's still the same thing. I have cosine of x times 1 plus sine of x, and in the denominator, I'm going to have 1. That's the first terms. Then the outer terms is going to give me plus sine of x. The inner terms, right here, will give me negative sine of x, and the last term, negative sine times sine, will give me negative sine squared. Okay. Now let me write my reasons in here. So this is multiplying fractions, and this is the distributive property going from step 2 to step 3 in the denominator. And in my denominator, you can see that some of these terms are going to cancel out, so the sine and the negative sine. So now I have this problem. Cosine of x times 1 plus sine of x, all of it divided by 1 minus sine squared of x. And it seems that we're going to go back to these Pythagorean identities again and again. So let me just set this up here. And let me remind everybody once again of the Pythagorean identities, and you really should have these handy when you're doing your work, and eventually commit them to memory because they are incredibly useful when we're doing proofs with trigonometric functions. So if you notice here, the first Pythagorean identity, cosine squared plus sine squared equals 1. So that means I can say that 1 minus sine squared is really equal to cosine squared. And if you notice here, this entire expression is the same thing as what we have here in our denominator. So we're going to substitute cosine squared for our denominator. Let me just get it. Okay. So again, substituting cosine squared into our denominator because cosine squared is the same as 1 minus sine squared. So in the numerator I have cosine times 1 plus sine of x, all of it over cosine squared. And let me state my reason here because that's very important. This is the Pythagorean identity, and it's the first one. Pythagorean identity number 1. Now at this point, we are very close to the end of our proof. You can see that I have a cosine and a cosine squared, and it's being multiplied, so it's a factor. So I can cancel the cosine and I can cancel the square here. So in the numerator, I have 1 plus sine of x, and I'll say so you're just canceling cosine x, okay, over cosine of x. And this is in fact the right hand side. If we look at our original proof that we're asked to do, we were asked to start here on the left hand side and show that it's equal to 1 plus sine over cosine, and that's in fact what we've reached here in steps 5 and 6, 1 plus sine over cosine. And there you have it. That's the end of our proof. And I just want to rewind a little bit and show you kind of the key step here, which is multiplying by 1 plus sine over 1 plus sine. Because a lot of the questions might be, well, why choose this expression here? Why not just choose sine, or why not choose cosine? Why do you have to go 1 plus sine? Well, the reason is, in fact, taking advantage of the difference of squares, which eventually leads us to this statement, which allows us to use the Pythagorean identity and replace it with cosine squared, which will allow us to cancel the cosine on the top. And at this point, if you're, you feel a little bit overwhelmed with doing these proofs, I mean, that's okay. This is a very, very challenging concept, and there's a lot of different ways to do this, and every problem is really completely different from every other problem. So there's some similarities, some strategies you can use, but everything is very much a different problem every time you see an exercise in your book or on the homework in class. And it takes a lot of practice, a lot of errors, a lot of mistakes, and correcting yourself to really be good at this. So just keep working on it. Keep working on it. Don't get discouraged. This is very hard. Even for me, before I made this video, it took me a lot of tries to get a really nice looking proof.